case you do, when you look at it, you can see definitely something is happening here with R. Then they say, find me the first term which is smaller than 128 over 729. Do you think it's going to go smaller, smaller, smaller? Because this is quite small. What does it look like? The A value is 2. And the R? 2 over 3. And it's not difficult to see it because there it is, 2 over 3. Double check. 4 over 3 divided by 2 is still 2 over 3. 8 over 9 divided by 4 over 3 is still 2 over 3. Make double, triple sure. Because now they're asking me which term will be smaller than. So I need to know the AR n minus 1 smaller than 128 over 729. Knowing that A was 3, knowing that R was 2 terms. And I'm solving what? Exponential equations, right? In actual fact, it's not an equation, it's a inequality. And it's an exponential inequality, which we don't really do as such, and I'm going to show you some funky stuff just now. Now, first of all, in an equation, how many of them are there? Linear, quadratic, exponential. If it's exponential and it's equation, whether it's an equation or an inequality, we're going to have the same basic principle. You've got to get the basis the same. What do you think the base is going to be? That's what I'm aiming for. I know what I'm aiming for. I've got to get this alone. So what am I going to do with that 3? Okay, and what's the answer?
The next side is 128 over 2187.
Alright, so now, thinking about what I just said, this should become what? 2 over 3. How would I do that? With prime factors of that, with my calculator. But don't put in 128 over 2187 in your calculator and say prime factors, facts. Put them separately. Because this, I'm guessing, is going to be 2 to the something. And this, I'm guessing, is going to be 3 to the something. And I think it's going to be the same thing since everything has to work out for my sum to work out. Okay, and what was it?
2 to the 7 over 3 to the 7.
2 and 3 to the 7, which I can then write like that. Calculator work. It is true that you've got to go prime factors like you did in grade 8 and work out it's 2 times 2 times 2, how many ever times, and there as well. And now, here comes the funky part. Your answer is n minus 1, 7, right? What do I write here?
You change sides.
Okay, now there's a rule. But the main thing I want to teach you today is if it's an exponential inequality, test your answer. Because you're going to forget what I'm going to tell you now. And then you're going to remember, wait a second, if it's exponential, sometimes the sign swaps around. What's the story? How come, where, what? If you remember that, you're going to test. If you didn't swap it around, now your answer is going to be n is bigger than 8. So that means which term is going to be less than? What is the term that's going to be less than? Which term? Term?
8.
It's not the 8th one. It must be bigger than 8. It can't be 8. It must be bigger than 8. So which is the term bigger than 8? Term 9. And the sum is now done. But now listen to the reasoning behind it. So if there's a fraction to any exponent there, and a bigger than and a smaller than sign, and that fraction, I'm writing whatever, doesn't matter, 3 and whatever, this will turn around if this is a fraction between 1 and -1. So it's saying the fraction is not quite true. because this is also a fraction. I'm saying, if it's 5 over 3 and it's n in 2, the sign will not change around. So saying if it's a fraction as the base, it always changes is not right. It's a fraction between 1 and minus 1, obviously excluding 0. A fraction between minus 1 and 1, but not 0. Because then that would be 0 to the power, and 0 to the power, and 0 to the power is? 0 to the power is? 1. 0 to any power is? 0. Okay, but okay, that's technical stuff. The principle I want to say is, if we do this exponential inequality, and the basis is a fraction between 1 and minus 1, then that sign will change around. Now that's a mouthful. That's a headful of knowledge. If you forget about this and you can just remember to go test it, you should be fine. Now think about it. The guy that didn't know this would have said that n minus 1 was less than and n is less than. Right? What does that tell you? That n must be 7. Now I'm thinking, the question was, which one will be less than that? I'm seeing it going smaller, 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 smaller. How come it's less than 8? Because all of them should then be smaller. Because this says anything less than 8 should be smaller. But this is the fourth term, that's less than 8. It's not smaller. This is the third term. The third term is less than 8. That should be smaller, and it's not. Are you getting what I'm saying here? It doesn't work. But if you go and work out the actual 9th term, you will see that it is smaller than this number. How would I work out the 9th term? AR to the 8th. Work it out and physically see what the answer is. It will be less than 128. But that's way too much effort. This whole 5-minute discussion on it basically comes down to, if the base there is a fraction between 1 and minus 1, the sign should change around. If it's not, it doesn't. If it's anything more normal, what would be your deduction? No problem, because there's no fraction. But there are fractions, but this fraction is not less than 1 or larger than minus 1, then it stays the same. But if it's between 1 and minus 1, the sign changes around. That's the facts that you must know. But if you can remember, if you're unsure, test it. See if n is bigger than, it should be 9. Work out the 9th one and it should be less than. If you did this and you work out 7, it won't be. And in actual fact, that means that all of them, 1, 2, 3, 4, 5, 6, 7, should be less than that number. Number 16 says, in a geometric series, the third term exceeds the second term. Here's with the English again, guys. The third term exceeds the second term by 6. Write that in maths. The third term exceeds the second term by 6. Are they the same?
No.
That's not true. The third term exceeds the second one. So which is the bigger one? The third term is bigger than. That's what exceeds means. By 3. 6, sorry. So this is 6 bigger. So must I say plus 6? Either minus 6 there or plus 6 there. Doesn't matter. Because now they'll be equal. If this is 6 units bigger than that one, to make them equal, you've either got to put 6 added here or subtract it here. That's fine. Plus, minus, it's an equation that I can go on with. And then it doesn't stop there, they say. And the second term exceeds the first by 9. So the second term exceeds the first by 9, so they're not equal. The second one is bigger by 9. So add 9 to the first one or the other way around. And guys, there's different ways of doing this. If I just read the mathematics and write it, the English and write it into maths, that's it. And then I can use my formula AR
In
2 and AR 1. Are you with me? And I've got an equation. This is going to be AR, was it 2 and 1? Right. Okay, sorry. AR to the 1 and A. Agree with me? Technically it's actually AR to the 0. But term 1 is A, which is AR to the 0. And now what? They love these simultaneous equations, right? What do I do to get them sorted? There's lots of things that you can
Coach,
do.
what is that?
Can I not get the R alone? It's possible. Then you're going to have a fraction here, A plus 9 over A. Substitute the R in here, oof, both times, and squares, oof, oof. I think it's better to go for A. If we got it together, at least, then we're gonna, and again, I didn't take out the R, although I could have. Because I'm aiming for, let's get A alone. Let's get A alone. Let's put them together. There's a method to the madness. I'm not taking out the full complete highest common factor for a reason. And then over here, AR minus A equal to 9. I'm taking out the A. And I'm substituting. Sorry, I didn't do it there. A is equal to 6 over R squared minus R. Meaning when I put these two together, I'll have 6 over R squared minus R equal to 9 over R minus 1. And my 9 almost looks like an A. Look at your handwriting, please. Be neat and don't confuse yourself and think a 9 is an A. Okay, and then I will cross multiply to which side does the R go? Are you with me? Just because ma'am likes to put the highest one at the top. No other reason. How would I simplify this now? Can I cancel out the R? Got it? Factorize. And if you factorize this, what is going on here? You've got to take out a common R. And if you do factorize, please keep in mind you should factorize with purpose. If something doesn't fall away, you've not done it with purpose. So we've got 6 over 9, which is 2/3, am I right? And R is equal to 2 over 3. Happy on that one? Okay, now, if you had swapped it around, it would have been 9 over 6, but it would have been 1 over R. So if it's 1 over R is 3 over 2, then R would be 2 over 3. Just check out the swapping around. What was the question? Question was determine the common ratio. So do I go on and try to find A? Done. Full stop. They asked me for R, I have R, I stop. If I go back and substitute the R there, I will be able to find the A. I can find the whole sequence. I can find term number 100. I can find sum of when I've done it first. But the question said find R, I've done R, I'm done. Let's go on to the next question. We now also need to not only do geometric sequences, but we also need the series. All that means is we're going to do sum of. So when I give it to you in this form, whether it's got semicolons for a sequence, or whether it's got pluses and minuses for a series, it doesn't matter. This is still geometric. First thing you've got to determine is your A is -1 and your R is -2 over 1. -2 over 1. It's actually +2 over -1, which makes it -2. Double check, -4 divided by 2 is still -2. +8 divided by -4 is still -2. I've tested it 3 times. So that means R is true. Now can I find term number 100? Yes. But the question is now to find S, the sum of the terms. Now listen to the question. I asked you to find the sum if it's to 2 terms. Or I could have just said, find the sum of 10 terms. But now they put it there dot 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 to 10 terms. So the Sn must be S. So now I'm going to substitute. Now guys, from the start, on the formula sheet you'll only find this one. And this is not there. There's a technicality here that actually doesn't really mean a lot until we get to converging and
Divergent.
sum to infinity. Then this makes a huge difference. For now, because we're not going to be working with infinity yet, it doesn't really matter which of the two you're using. It only matters that it's this one when it changes into sum to infinity. Okay, that's big words afterwards. You don't know what I'm talking about. I just want to show you that that is actually the same. If I have a r to the n minus 1 over r minus 1, and I have r to the n, I'm saying that that's exactly the same. For one reason. If you multiply the top with a negative and the bottom with a negative, is this still the same thing? Timing the top and the bottom with a negative, meaning I'm timing with a plus. What changes? Well, anything you like, but I'd like it to go in here, which will make this effect. And I'd like it to go here as a bracket, so to make this effect. Do you see it? Why I say that that is actually the same thing. So if you time there with a negative, both of them, and there with a negative, both of them, these two equations are exactly the same. But there's reasons behind it. So if you go and substitute into any one of the two, please bear with me quickly. And please remember what she just asked, that A is now going to be negative 1, R is going to be negative 2 to the power of 10. This is negative 1, it's not by the end, like we used to with the Tn. And this is going to be negative 2 minus 1. We're going to talk about it again, that it doesn't really matter which one in life. Sn is going to be equal to, just give me an answer on a calculator, then we're done. Again?
341.
Somebody concur? That's it. Guys, your homework? Okay, just those two questions for Monday.